Assalamualaikum, welcome back to another exciting video. In this video we will learn how to work on Autodock Vina. For this just click on Autodock tools, then the window will be opened like this, and next you have to do remind me later and maximize the size of window. In previous video we have formed a protein file in PDB format, and two files of one is of inhibitor and one is of ligand. In ChemDraw we draw the structure and save its file in PDB format. Now first step is open Autodock, go to read molecule and open the file of a protein that you have prepared in Discovery Studio. So this is the file. I just open this. This is the protein which is free from water molecules and the ligand. Next you go to add charges to this protein, and okay. Now you have to add hydrogens, but keep in mind just add polar hydrogens and okay. Now go to grid macromolecule, choose your protein, select molecule and save its file at desktop, and keep in mind save this file in pdbqt format. So .pdbqt and save it. And now you go to grid box and adjust this grid box at 26. XY dimensions at 6 are best, and spacing you keep it at 1. Now go to file, output grid dimension, save it at desktop in the form of text grid text. Now grid file is saved. Now go to file, close saving current. Next is you have to add ligand, input, desktop. From here you have to change it to all files, and now you have to select first we will select inhibitor, that is a standard. Okay, that is inhibitor. Now next go to input, torsion tree, choose torsion and done. Next again go to torsion, set number of torsion are 7. Now dismiss, output and save this file as a pdbqt. For precaution you have to write .pdbqt and save. In the similar way you have to save a file of inhibitor on your desktop, and in same way you have to save your file of ligand. So I also prepare a file of ligand on desktop. Now to prepare the file of ligand, I simply go to file, read molecule and open this file that I have prepared in Autodock, that one. After this I adjusted grid to 26. Okay, I adjusted to 26 1, and file, output. Next go to ligand. Now I have opened the file of ligand L that I have synthesized, this one, all files and ligand. Now simply torsion tree, must type here .pdbqt. As you seen, two files of ligand, one of ligand and one of inhibitor is saved on desktop. Now close this. Next you have to open command prompt. Before this you have to do one thing. Cut this file of protein and first of all inhibitor, control X, and save this file in folder of Vina. If any files are present here, then delete them. I simply paste this here. Okay, next you have to open grid file. This is the grid file, and now go to Vina, open conf.txt file. Okay, here in grid, these are the centers given. You have to copy all of these center. This is a value of X center, this is value of Y center, and this is value of Z center. So simply what you have to do this here, copy the value of X center, control C. As I have already run Autodock Vina for this receptor, that's why these values are same. If values are not same, then you have to copy this value from here and paste this value here. Next, in the same way, you copy this value and paste value here, and also this value. Okay, and after this you have to correct your receptor name. What is the name of protein receptor? That is 1B2Y. It is also already written here 1B2Y because I have already run this receptor. If other name is, for example, here is written like this, then you have to correct it to 1B2Y. And I save a file of two inhibitors. One is of inhibitor, another is of ligand. As I copy my file in Vina is of inhibitor and its name is inhibitor, so I simply write here I is capital, so I capital inhibitor. Spell should be same as this file. Okay, now what you have to do this, save, close this, and now open CMD file. In CMD there are the commands for Autodock Vina. So first of all you have to change your directory. Write here cd desktop, as we have a save file of Vina at desktop. Next cd Vina. Then when Vina is looking like this, then you have to copy this command and paste this command here, control V, and press enter. It will take some time and give the result of docking, give the binding energies of protein and ligand. It will give 10 values of different poses with different binding affinities, and this is the values of binding affinity of inhibitor with a protein. 9 values are given. So this was all about how to calculate binding energies of protein and ligand. Here binding affinity results are shown. First pose have a binding affinity of -5.8, and it has RMSD value 0.00, and best mode is also given here. Next, what you have to do is copy this command, and before this you go to Vina folder and change the name of output file. Simply you give this name as it is, but you have to type it. If you have not typed this um, name, and then it will cause some error. So again I give it name out.pdbqt. Yes, and now come here and copy that command and paste this command here and press enter. When you press enter, then different files will be saved from 1 to 9 with different poses with different binding affinity. Now what to do next? We go to new, create a word file 1b2y. Okay, open this file. What you have to do, you have simply to copy this control plus C, and as these values are the binding energies of inhibitor. So for remember, type here inhibitor docking results and paste these result here. Now what to do next is, again open a command prompt. Before this, go to Vina. Okay, first we complete one results, then we will do another thing. Go to pymol, file, open, from Vina folder open the file of protein. Next open the file of this one file, this one file. Here protein is shown. Okay, now you simply go to file, export molecule, save at desktop. You have to save in the form of PDB and give it name. As this is file of inhibitor, so I simply write I0. Okay, next go to reinitialize everything. Again go to open, desktop, Vina, again open file of protein, open file of this one. Now in the similar way you have to export this file, save, desktop, PDB, as I give this name I1. Again go to this, to give this name I2. Again reinitialize everything. Do it 3 times. Again protein. Now take third file. Now go to this one and open Discovery Studio. Now you have to check 2D interaction of your protein and ligand, as you have taken binding affinity values. Now further is 2D interaction. Now open Discovery Studio, go to File, Open, and open the file I0 to check the interaction of inhibitor and protein. Now right click, apply field force field. Next change the mode of mouse to rotate. Go to non-bonding interaction. Now interaction option, and remove the operation option show intramolecular. If a non-classical, then also remove this and simply show 2D diagram. Okay, next go to alkyl interactions are not favorable and carbon hydrogen bond interactions are not favorable, so tap on this, rotate and press del key. Again press del key. Again remove carbon hydrogen interactions, del. Go to display style, this one, atom stick. Now maximize the screen and increase its size as possible, and then go to file, save as desktop and in the form of image. Keep its pixel 5000 and press OK. Now check if the file is like this in black color, then again go to Discovery Studio and save this file. (4,000) 4,000 pixels. Now this file is clear, interactions are seen. It means you keep pixels at 4,000. 5,000 pixels or not 5,000 pixels are not working for your laptop, so use 4,000 pixel. And in this in the same way you have to see also interaction of other poses. So I have selected these three residues and I label this. Go to labels, add amino acids, attribute, set attribute to this one, times New Roman, and keep its size 20 and give this color black. Okay, and also go here, visualization, publication quality, and now go to file, save as, desktop, 4000 and OK. 2D and 3D interaction file of inhibitor is saved at desktop. Now in the same way you have to check the interaction of 2D interaction of inhibitors file I1, I2, I3, and next you have to see the interaction of ligand. So I do this and I compare with all interactions after a few minutes. Okay, I have here checked 2D interaction of all of save file of inhibitor. So I show you this is the 2D interaction of inhibitor and amino acid residues. As you have seen this here, hydroxyl group show hydrogen bond interaction with this amino acid, and all of these also show amino acid interaction with both of the showing hydrogen bond interaction. Okay, and now you can see this inhibitor pose 1 also shows same type of interaction. This is same and this is same. It means that there is no difference in interaction of the file 0 and 1. So I remove this. Now we have to compare something, as this interaction and while the second pose is showing more interactions. As I said that alkyl interaction was not favorable, but pi alkyl is somewhat favorable, so we keep this. But carbon hydrogen bond interaction is not favorable, so I simply select this and remove it. This is of 2, so I simply delete this interaction. And also I show you third pose interaction. In third pose interaction, this interaction is not favorable, so I simply delete this. Next is alkyl interaction is also not favorable, I also delete this. If you see this here unfavorable acceptor interaction is seen. This is not favorable, we have to delete this. Okay, now if we compare three poses with different interaction. First of all, this is showing 1, 2, 3, 4 type of hydrogen bond interaction, and in this image this is showing 1, 2, 3, 4, 5, 6. This is showing 6 higher type of hydrogen bond interaction with different amino acid residues. Okay, and in this 1, 2, 3, 4, this is showing 4 type of interaction. Only hydrogen bond interaction are also show unfavorable, so we do not keep this. Okay, we keep these two files of 2D interaction. Now as pose 1 is showing 4 type of hydrogen bond interaction, while that of this is showing more hydrogen bond interaction, we favor that pose which will showing more interaction and more favorable, as hydrogen bonding is favorable interaction, so we keep this file. And when we report this pose, then we mention only this pose binding energy. As I show this to you, this is inhibitor in which second pose showing minus 5.7 binding affinity, while that of pose 1 is showing minus 5.8 affinity. These are very close values, so we will not consider this value. We will consider this value and report this value, that because it is showing more type of interaction. So I simply remove this, and I favorable this one interaction, and also mention its binding energy. Now I will show you show the comparison of ligand and inhibitor. I complete all the docking process in Autodock Vina of ligand that I synthesize, and the binding energy of this ligand is minus 5 minus 10. That is more favorable as compared to our standard inhibitor. So now further I prepared it some pdb file in Autodock PyMol, and next I see it's a 2D interactions in Discovery Studio. So first of all I open the 2D interaction of ligand 1 file, then ligand 2 file, and then ligand 3 file. Okay, now compare all of these. Alkyl interaction is not favorable, so we have to remove this alkyl interaction, but we can keep pi alkyl interaction, while in L2 file it is showing pi hydrogen bond donor. We delete this interaction. Next it is showing pi alkyl type, we keep this. Okay, in pose 1, if we see here it is showing pi alkyl interaction, pi T shaped interaction, pi anion, pi sigma. If we compare all of these, then L3 file is showing very less interaction, so we do not favor this, we remove this. Okay, now we have to choose L1 or L2 on the basis of favorable interaction that they are showing. If we see here, L1 is showing interaction of minus 10.10 with binding affinity, while L2 is showing minus 9.7. On the basis of interaction we compare both. This is showing pi anion interaction, while this is showing pi cation interaction. Okay, in this it is showing pi T shaped and pi sigma, while here it is showing pi T shaped, pi stacked. Pi stacked and pi T shaped are also very favorable interaction. So on the basis of pi T shaped and pi stacked, we favor L2 interaction as compared to L1. In this it is not showing pi stacked, so we reject these interaction. Okay, and we favor this interaction, and go in display style, we change its style and save this file for further analysis, or for report it in our document or in a paper. And now I show you something. Okay, we see the interactions of ligand and inhibitor. Inhibitors pose 1 show minus 5.8 binding affinity, while ligand my synthesized compound show minus 10 binding affinity. This is our standard compound that we keep, and we compare all of our values with that binding affinity. As this is showing very good affinity as compared to this one, it means our synthesized compound is very good. And on the other hand, as we compare only ligand docking result, in this we will see that showing more binding affinity, but with comparison to interactions, second pose is showing more interaction, so we favor this and report this binding affinity value. So this was all about how to work on Autodock Vina, and comparison of docking result. One is a standard compound and other is synthesized compound. So if you have any question, please ask in comment box, and please subscribe my channel, and thanks for watching this video. Allah Hafiz.